The rules for multiplying and dividing exponents are slightly different than adding and subtracting. Let's start with multiplying, and let's take a look at just a basic case with one variable, such as 2x squared times 3x cubed. Now it's important to remember what x squared means. It really means x times x. And x cubed really means x times x times x, 3 times. So in effect, we have 2x's over here, 3x's here, or 5x's total. This can also be written as x to the 5th. Lastly, I will just multiply the constant terms. 2 times 3 is 6. And carry that down for my result of 6x squared. When multiplying terms with multiple variables, the same rules apply. We don't have to write all of the x's out as I did in this step here. Instead, we can follow the basic rule of adding the exponents. Notice 2x's plus 3x's resulted in our exponent of 5. So as a shortcut, I can multiply the constant terms, 2 times 3 is 6, and then add the exponents on the same variable. Notice this x does not have an exponent, so it's really a 1. I have an x term with a 1 and an x term with a 2. 1 plus 2 is 3, and a y, 3, y, 4. 3 plus 4 is 7. Division works slightly differently. Let's take a look at what's going on there. 6x cubed divided by 2x squared. What does this mean? It means 6 times 3x's over 2 times 2x's. Now recall, with fractions, we can cancel out the same thing on the top or the bottom. We also can divide our values out in front, or our constant terms. 6 divided by 2 is 3. And notice when I cancel, I have only 1x left. As a shortcut, instead of writing these out and canceling, I can take my exponents and subtract them to result in the new exponent. The same thing works if I have multiple variables. I'm going to start by dividing my constants. 4 divided by 2 is 2, and subtracting my exponents. There is a 1 here that you cannot see. 4 minus 1 is 3, resulting in x cubed. And looking at my y's, 5 minus 2 is also 3, resulting in y cubed. That sums up the rules for multiplication and division of terms including exponents.